Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
Are you looking at an online institution that can teach you and help you to understand, enjoy, and apply the beauty of high engineering mathematics? Or have you ever been looking the place where actually that you can enjoy the beauty of high engineering and scientific mathematics? How are you, everybody who is watching this video? I'm very happy to welcome you into this fantastic moment, all national, international, and even family students or family viewers who are watching this video. My name is Olenjolain, TAYAI single. I'm a Tanzania. Simply, yes, you can call me Olenjolain. So instead of calling me maybe Olenjolain TAYAI single, you can just call me Olenjolain. That is enough. I thank God by His own grace, I'm a righteous citizen of the United Republic of Tanzania, and this is our national flag. I would like to welcome all the international students into a beautiful country to come to enjoy the presence of God and beautiful people in our beloved country. So I would like to take this opportunity to welcome you into this fantastic moment of learning and into this fantastic moment of solving real life problems. So whether it's your first time or this is your second time or third time, so your nth time, I would like to tell you that I thank God by His own grace today I have a good news for you. Firstly, I thank God who have built the gift of teaching in me. Secondly, I thank God who have built the gift of mathematics in me. I am mathematics and mathematics is me. I am teaching and teaching is me. Thirdly, I thank God by His own grace who has built in me His gift of engineering. So in this program, I'm going to stand in at least 3 positions. I'll be standing as a mathematician, I'll be standing as engineer, I'll be standing as a teacher simultaneously. And that is by the grace of God. But in case that you don't trust what I'm telling you, just wait within a moment, you will realize and appreciate yourself and give God all the glory and thanks because He deserves, because there is a God at work in me. So let's take this opportunity to welcome all our online undergraduate or even non-undergraduate students, international and the national students, into one of our online institutions that called Online Undergraduate Polytechnics Institute of Tanzania in square bracket Olenjolain M. Simultaneously, because I'm teaching mathematics, I would like to welcome you to one of our official YouTube channel that's called Online Undergraduate Institute of Tanzania in square bracket Olenjolain M. The name itself just means the name of the channel, the name of the institution start with online. It means that we are sharing our contents online. The second word is undergraduate. It means we are focusing to undergraduate students or providing contents specifically for undergraduate students or bachelor students or first degree students. Polytechnics, so it means we'll be dealing with different techniques at the means of polytechnic. Poly means many. So these institutions, in this institution, will get benefits of different techniques in engineering and science. Then institute, this is an institute, is specializing in particular knowledge of 40 applications of engineering and applications of science in solving real life problems of Tanzania. So, okay, these are the locations where the institution it is, but again, so I'll be using the curriculum and the syllabus of United Republic of Tanzania, which I'll be focusing on either NACTE syllabus or TCU syllabus. So the name had a meaning, it's very powerful, but you can be asking yourself another question. Well, I understand. Thank you for welcoming me in on Online Undergraduate Polytechnic Institute of Tanzania. But I want to know what is your vision. That's a very good question, and it's a biblical question according to Proverbs 29 verse 18 that is saying that where there is no vision, people perish. So when we are asking us about the vision in our mind, and then ourselves, we have to seek the purpose of this program. Why are we doing this program? What are we doing? And then to whom are we doing this program? Wonderful. So the answer of that questions, we thank God by His own grace. We have this vision as an assignment of teaching and training undergraduate students to extracting knowledge, understanding, wisdom from the classroom instructions in fundamental and core modules of engineering and science at this moment, and combine it with knowledge, understanding, and wisdom that we are going to teach our students to extract it from the Word of God written in the whole Bible in order to solve real-life problems. So the main objective of OPITO, which are abbreviations of Online Undergraduate Polytechnic Institute of Tanzania, is to teach our students to think differently and especially thinking outside the box. What does it mean? We have a classroom we have a classroom education, we have a classroom engineering and scientific educations, and we have real life engineering and scientific education. So for us, so when you say real life, we are getting out, or we are teaching you and challenging you to get outside of the class and then to check the engineering and scientific real life problems that need the solutions, and the person who has to or who is responsible to solve, it's you who is watching this program at this moment. However, that we have so many specific objectives. We are here to prepare our undergraduate students in the year continuing assessment. The second specific objective will be preparing you to get prepared well for your final examination. The third objective, we are here to help all our undergraduate students to understand the modules or courses that we are going to teach them step to step. But the fourth specific objective, we are here to challenge our undergraduate students and show them the opportunities that waiting for them or that they can take part of, and then having meaning in life and apply the classroom instructions in solving real life problems. Again, possibly it's your first time to join me. You're warmly welcome. I'm very happy to have you. But in case you have already registered yourself, so you're permanent students of OPITO, one thing I want to remind you. Please, we are sharing our contents online, and every day we are adding a certain video, or we are publishing a particular contents in form of video. So make sure that you visit our official YouTube channel at least every day for you to get good news. That from what? Online Undergraduate Polytechnic Institute of Tanzania. But if it's your first time, you're warmly welcome. Welcome to the first year of undergraduate, because we are going to speak with first year undergraduate students or bachelor students. You're warmly welcome. And then, let me take a minute to navigate you how you can register yourself permanently. And our registration is free. It's one lifetimes. So if you register right now, then it's over. You don't need to register any furthermore. Okay, are you ready for that? For the registered students, you can just listen these few steps so you can share with other distance students who are in undergraduate level. So the first step, if you don't have an email, you can create or open a new email. It can be Yahoo email or a Gmail. Then the second step, sign in YouTube by using your email. So you'll be asked to fill an empty blank, your password and username. The third step, we ask you to search OPITO. OPITO is abbreviations of Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAI. So you can search this one. Don't search these names not there. Simply in the search space of in YouTube, just to search this name, Online Undergrad Poly Institute of Tanzania in square bracket OLENJOLAI. Once you search, you will see our welcoming poster, the round buttons, which have a profile picture of our national flag, that is called the Tanzania national flag. So when you are there, you're already in OPITO welcoming flag. So we ask you to click, so beside it you'll see the name of our official YouTube channel. It's not OPITO, this I wrote just for presentations, but it's abbreviations of what? Online Undergrad Poly Institute of Tanzania in square bracket OLENJOLAI. That's the abbreviations is OPITO. You see the number of videos, the number of subscribers, number of students who have already registered. So if you be registered yourself, the number will increment, will increase. So we ask you to click the round button, so 40 of Tanzania national flag. Then you'll see the horizontal toolbar written songs, video, playlist, community, channel, about. So again, at the bottom of this video, we ask you to see the button written subscribe. This is very important button for the new student or for the new viewers. Click these buttons once, then the text will change from subscribe into subscribed, the past details. And then from there, you'll see an icon of the bell beside it. We ask you to click it once. Once you click it once, you'll be prompted with 3 options: all, personalized, and none. We ask you to choose the options of all, and then from there, you have already registered yourself permanently. Whenever we add any new video, you'll be the first student to get notification from the YouTube community. Okay, number 6 is these are the few steps for you to take advantage of our content. We used to organize every topic, every module, every course in terms of playlist. So we've created a playlist called Gamma and Beta Function, where you'll find the collections of all the videos from lecture 1 to the last lecture of Gamma and Beta Functions at the topic. So click playlist, then go to the Gamma and Beta Function. You will see the well-organized or the systematic arrangement of lectures. Number 7, again, we know that you'll enjoy our contents. And then the next questions will come in your mind. How can I share this good news with other distant students? Because there's no limitations of our contents. You can access at any time and anywhere. So click the buttons written share at the bottom of this video to share this video link via social media. For example, WhatsApp, Facebook. You can share the video links through Facebook, through TikTok, through Twitter. You can share it also through Telegram, through Instagram, through Facebook, through email, etc., etc. So again, welcome again in Obito. Are you ready for today's session? Okay, so just let me navigate to you. Welcome into Departments of Higher Engineering and Scientific Mathematics. The module or the course of the day is called the Advanced Calculus. Very interesting. And I'll be focusing according to DIT. Remember that my focus, I'll be using the syllabus and curriculums of DIT. This module at DIT, the National Institute of Technology, and many institutions or colleges in the world is being taught to the first or second year Bachelor in Engineering or Bachelor in Science students, Bachelor in Science program. We are in chapter 1 called Gamma and Beta Functions. This is lecture 8. We are done with other 8 lectures from lecture 0 to lecture 7 and stated as beta function, where I'm going to introduce to you the beta functions today. That's why that simply I call it beta function. Are you ready for that? Okay, so if you're ready, let me do the quick review first of all before we dive into the beta function. So quick review. Say with me, quick review. Quick review of, let's say, lecture what? So let's say lecture 0 to lecture 8 to lecture 7. So let me start with the big picture. In the big picture, we have something we call it calculus, right? Say calculus. So in calculus, we have 3 branches. The first one is differentiation. The second one is derivative. The second one is called integration. The third branch of calculus is called the differential equation. So under integration, we have mainly 2 types of integration. Okay. The first one is called the finite integral. And the second one is called infinite integral. So under infinite integral, also we have 2 categories. Okay, we have 2 categories. 2 categories. We have proper integrals, and also, okay, this sometimes we call it proper integrals. And here we have what? We have type. We have this is just proper integrals. This is called improper integral. So we have type 1, we have type 2, we have type 3. Okay? So this type 1 and type 2 are the one that gives us what? 2 types of functions. Beta function, which is we call it the beta of m, n, and what? Gamma function. So the next question, so we've been discussing about gamma function. And if you do remember, we say the general formula, it's integral from 0 to infinity, e power negative x power n minus 1 dx. And also we discussed about some properties of beta, of gamma. Gamma of n plus 1, we say this is equal to n factorial. Another property, gamma of n plus 1, this is equal to n gamma of n. Another property, we say that gamma of n times gamma of what? 1 minus n, this is equal to pi over sine of what? N pi, etc., 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 etc. So you've discussed so many information today. Let me take you into the new concept of beta function. Say with me, beta function. Are you ready to receive the good news? Okay, so let us get inside beta function. So the fundamentals, so let us start with beta function. So this is the introduction of beta function. Are you happy? Are you ready to receive good news? Okay, so let us go inside the session. The fundamental question that we have, what is beta function? What is beta function? That's the fundamental question that we have on the spot. So beta function, literally we can define beta function is a special function. It's a special function of improper. It's a special function of improper integral. It's a special function of improper integral. So we can add this, which is denoted as beta of m, n. So that's a simple definition of of beta function. Beta function is a special type of improper integral which is denoted as beta of m, n. That's a simple definition. So when you say special integral, special improper integral, I taught you about improper integral in lecture, something like lecture 0, lecture 1, I don't remember exactly, but lecture 0, between lecture 0 and lecture 1, we can review. I taught about a special integral as just introduction, or I was laying up the foundation of beta and gamma function. Okay, so that's a simple definition of of beta function. Okay, so how do we define beta function mathematically? So we say that mathematically, the beta, the general formula of beta function can be expressed in 4 different forms. These are the first one, we call it, you can express it in Cartesian form. Secondly, we can express it in polar or trigonometric form. Thirdly, we can express beta function in factorial notation. Third and fourth, we can express beta function as what? We can express it as gamma, can be expressed in gamma function. So we expect it to have 4 different forms of formulas of beta functions that will be using them in different circumstances. Some of form are universal. For example, the only one which has limitations is factorial notation because it's limiting the value of m and n to be integer, to be a positive integer, while the remaining three functions or three forms can accept any value of m and any value of n. Okay? Remember that we are focusing on how we can solve or we can apply the concepts of beta function to solve problems of integrals, of improper integrals that will be given. Okay? If you have any question in this lecture, I love so much questions from my students. So obviously, when I teach physically my students, I used to spend almost 30% of every lecture to give my students to ask you questions. So if you have any question about what I have been teaching you, or you have any question about what we are covering today, don't hesitate to ask in the comment sections and read the descriptions below in order for you to get more information about our different programs. Okay, you can pause the video and copy all of these 7 steps that will help you to navigate and to be successful in our online training. Okay, so my dear student, I know that you are asking yourself so many questions. Maybe you have been stressed. I want to ask you that be free from any kinds of distress about learning because you are in homes of understanding. So let us begin with sorting the formula, the Cartesian formula of beta function. So let us start from this one. Cartesian formula of beta function. Remember that in most cases, not in a book that have explained beta function in this arrangement. I'm just following the techniques that have been taught by God when I was preparing myself, but I always used to be correct or to be right on what I'm doing. So Cartesian formula of beta function. Beta function. Okay. So the Cartesian formula, or simply formula of what? Formula of beta function is given as what? Beta function of m, n is equal to integral from 0 to 1. Then you have x power m minus 1. Then open bracket 1 minus x power n minus 1 dx. This is very important formula. But this is in case of if it independent variable, it's x. Alternatively, if the independent variable is not x, is for example it is u, that will be seen, we'll see it later on as we continue this topic. Beta of m, n is equal to integral from 0 to 1 of u power m minus 1, then multiplied by 1 minus u power n minus 1. So then du. So this is another form of beta function. So you have to be careful about independent variable. Which independent variable are you using in that part of solving a problem? Alright? So even if independent variable, it can be R, it can be any other letter as well that you let it in during your journey of solving a problem. Okay, so if this is the case, so simply this is just a beta formula. But we call it, I call it Cartesian because it uses polynomial functions, so polynomial components. If you have any question, don't hesitate to ask in the comment section. Do you understand? If you don't understand, ask in the comment section. If you understand, give us feedback in the comment section there in this video, because we read comments from our students and we are waiting them with great joy, because we see that now we have a complete class when the teacher is teaching and students giving feedback, whether they understand or they don't understand, and asking questions. That's the first form, all right? Are you ready, ladies and gentlemen, for the second form? But let me deal indeed after this first form, before we go into the second form. Then we say that in mathematics we used to say that beta of m comma n, beta of m comma n converge for what? For m greater than 0 and n greater than 0. We have divergence. If you do remember, that's what we taught you on left. We have divergence and the convergence. For example, we have divergent lengths and convergence lengths. So converge, so it means the value of beta comma n converge when the value of m and n are any numbers greater than what? 0. That's the very important point, my dear student. So from here, we solved the almost 19 questions. So I can add, you can add the example 20, example 18, 19, and example 19. Just example 19, example 20 for yourself. So this one, just you call it example 21. It means that you have to solve at least, I taught you 18 examples in gamma function. So 19 examples, something like 18, between 18 and 19 examples. So add at least one to make it 20. Okay, so this is the example 21. So that the question we can solve simply by using this beta function, right? So let us use this formula of beta function, solving example 21. Then I will take you into all the other remaining 3 forms of beta function. So stay tuned, don't quit. Okay, so the question is, show that beta of m comma n, okay, this is equal to what? Is equal to beta of n comma m. This in set we used to call it commutative property. Say with me, commutative property. Say commutative property. It's just like a commutative what? Property. Commutative property. So show that beta of m comma n is equal to beta of n comma m. That the responsibility that we have as children of God, as engineers, and that the challenge. So let us think how we can solve. Solution. We are going to follow some steps on solving it. So you have to show that beta of m comma n is equal to beta of n comma m. Okay. So we have to show that beta of m comma n is equal to beta of n comma m. The first step, we say that, so suppose this is equation 1. Consider left hand side of what? Of equation 1. So the left hand side of equation 1, we have beta of m comma n. What is formula? Its formula is integral from 0 to 1. Then we have x power m minus 1, 1 minus x power n minus 1 dx. So we have to use this formula to deduce that. Also, this formula is the same, or gives the same value when we interchange the variables of m and n. So you know that the second step, we are going to let u is equal to 1 minus x. Isn't it? Yeah, let u is equal to 1 minus x. So what are we going to do in the second step? We have to change the variable. So before we let, you say that change the variable. So change x into u. So simply say that change variables, plural. Change one variable into another variable. How do we change it? let u is equal to 1 minus x. U is equal to 1 minus x. Make x the subject. If you make x the subject for this case, so we have what? So we have u is equal to 1 minus x. So we say that minus 1 both sides, and on this side also minus 1. So we have u minus 1 is equal to negative x. Divide by negative 1, divide by negative 1. So x is equal to 1 minus u. Okay, that is. Again, let us differentiate. We have u is equal to 1 minus x. So let us differentiate u with respect to x. Du dx is equal to d dx of 1 minus what? D dx of what? Of x. Okay, so this makes what? Du dx is equal to what? D dx of 1, if you differentiate constant, you get 0, right? But if you differentiate x, you get 1. Okay, so this makes what? In case you find that I'm teaching and writing quickly, you can pause the video and copy the notes, then continue. This is the goodness of the digital learning. Okay, you can learn in a different way. So here we have du is equal to what? Dx is equal to what? Negative 1. So multiply by dx to both sides. So we have du dx multiplied by dx. This is equal to negative 1 multiplied by dx. So du is equal to negative dx. So let's make dx the subject. So to make dx, we divide by negative 1. So we say that this one, so we need this dx is equal to negative du. And also we need x is equal to 1 minus u. Don't round this in exam, just want to label the important information that we need. Okay? So remember that this is equation 2. Okay, so we have these values. In case that we change the variable, okay, we change the limits. So we go to the, so right now we have to change the limits. So change the limits, we have let u is equal to 1 minus x. The first limit, it means lower limit, it's when x is equal to 0. So 1 minus 0, the answer is equal to 1. Then we have what? The upper limit. Okay, the upper limit, let me use p, the upper limit. Then we have 1, the value of x is equal to what? It's 1. 1 minus 1 is equal to 0. Okay, so those are our new limits. So we go into the third step. The third step right now, okay, the third step right now, we say that, so we have some equation. Suppose that this is equation 3, suppose that this is equation 4, suppose that this is equation 5. Okay, so we say that substitute equation 2, equation 3, equation 2, equation 3, equation 4, and the new limits. New limits in equation 2. Okay? After doing that, if you substitute, on the left hand side we have what? Beta of m comma n is equal to what? Integral. The lower limit today it is 1. The upper limit it is 0. Then here we have x power n minus 1. What the value of x? X is 1 minus u. So here we have 1 minus u power m minus 1. Then we have what? Again, we have what? 1 minus x is equal to u. So instead of 1 minus x, we have u power what? n minus 1. Then multiply by what? Dx. What is dx? Dx, it's negative to u. So we can simplify. Okay? I believe that you enjoy solution of example 21. Tell me in the comment section if you do. Okay. So from this fact, we say that beta of m comma n, this is equal to what? Is equal to integral from 1 to 0 of what? Of 1 minus u power m minus 1. Then we have u power m minus 1. Then negative what? negative du. Okay? Okay, so if that's the case, we can rearrange them in this way. Listen carefully. That beta of m comma n is equal to negative of 1 to 0, right? Then we can say u power n minus 1, then 1 minus u power m minus 1 du. So listen carefully, this technique. So this is the first step. First step, say that not before. Whenever you're integrating an integral from a to b, a certain integral of f of x dx, not this is equal to negative of integral if you change the limit from upper, you change the upper limit into lower and lower into upper. So from b to a of f of x dx. Okay, that's the technique. So this one is equal to this one. So what does it mean? Remember, we had our equation what? We had our equation 60, which is beta of m comma n, which is equal to negative integral from 1 to 0. We have what? U power n minus 1 and 1 minus u power m minus 1 du. So this was equation 6. If that is equation 60, say okay, wonderful. If that is equation 60, so if you want to apply this concept, we have what you have on the right hand side, we can change it into what you have on the left hand side. So it means that we said if you have b to a but negative of f of x dash, because this function should be derivative, dx, this will be equal to what? Integral from a to what? To b, then so f of x dash dx. So if you consider this equation, the right hand side of this equation, that this means that integral from what? 1 to 0 of what? U power n minus 1, then 1 minus u power n minus 1 du. This is equal to what? So this is negative. So makes become what? Positive. And then we change the limits. The upper limits become lower limit, and the lower limit become the upper limit, 1. The function remains the same, u, then you have what? n minus 1, then you have what? 1 minus u, then you have what? n minus 1 du. Okay? If that is a fact, what does this mean? So we say that the integral from 0 to 1 of u power m minus 1, then multiplied by 1 minus u power n, not m, yes, okay, power n, no, this is n, not m, u power n minus 1, yeah, 1 minus u power what? M minus 1 du. So the first letter means that the power of u, it's a 1 start at the first component or first what? Yes, first number of what? Of beta. So this is equal to what? Beta of what? Of n, because n is the power of u, and m is the power of 1 minus u, comma what? Comma m. This is similar to when we say beta of m, so m become the power of x, and n become the power of x, 1 minus x. Similarly here, n become the power of u, and the n become the power, n minus 1 become the power of 1 minus u. So it means that the beta of n comma m, and this makes what? Equation what? Equation 7. So we have considered the left-hand side of what we have to prove, and we found the left-hand side is equal to the right-hand side. That's what we had there. So therefore, so we say that beta of m comma n is equal to beta of n comma n. Hence, show that the answer of example 21. Did you enjoy it? You have to make sure that you absorb this information. Don't cram. This is not a home of cramming. This is the home of understanding. One of my weaknesses in learning for more than 30 years right now, I've been learning different issues informally and also formally, is I used to fail to cram. So I train my level best to understand, and according to the grace that God has given me and the gifting, whenever I understand, whenever I learn something, I know I have a responsibility to teach others. Okay? Is it interesting? Okay, fine. So we've solved the example 21. Then we have to keep moving. So ladies and gentlemen, if you have any question, and give us feedback whether you understand what we are teaching you in the comment section. Okay? Okay. So ladies and gentlemen, we say, okay, so right now we go into the second form. We say the second formula of 40 of beta function. Do you know the second formula of beta function is in which form? Is polar or trigonometrical formula of what? Of beta function. And the good news, we can derive this formula from Cartesian formula of beta function. Just write the title and then think for a moment. You can pause the video and try to derive yourself. So from here we can have a question. Okay, derive the trigonometrical formula. Trigonometrical formula of beta function by using its Cartesian or polynomial form. Simply means this will be given. Beta of m comma n is equal to integral from 0 to 1. Then you have what? X power m minus 1. Then 1 minus x power n minus 1 dx. So that's the question. You can pause the video. We are using the technique, we call it active learning. So you can pause the video and try to solve this question yourself. Okay? Try it. Then I'm coming to do correction to help you. Okay. Sick? Okay, so I think, thank you for trying. Thank you for trying. Let us do the corrections and see how far you are. Okay, so solution. So to derive this formula, the first step, we say that we know beta of m comma n is equal to integral from 0 to 1. Then we have x power m minus 1, 1 minus x power n minus 1 dx. Okay, so this we can call it equation 1. Equation 1. So the second step, we go to change what? Change the variable. Change the variable of equation 1. From what? From x to u. From x to theta. So in order to do that, we let this. Let x is equal to sine square theta. So this is equation 2. Let x, this x, is equal to sine square theta. There's the meaning of doing that because we are going somewhere. So because we are going somewhere, remember beta, it's a Greek alphabet. Gamma, it's a Greek alphabet. Okay? So, we have let x is equal to sine square theta. So we are changing the variable. We follow the same steps as the steps that we did when we've been changing x into u in example 21. And we'll be repeating and doing these steps even in solving different problems of beta function. So I'm going to repeat these steps. You should not get tired. So we have x is equal to sine square theta. Okay. So this is one of the expressions that we'll need it. So let me round it. Again, if that the case, so yes, okay. So if that the case, we have to check our formula. We know the value of x, or we have changed x into theta. So you have to think to change 1 minus x into theta. How do we do that? So in our equation 1, we have 1 minus x. So according to the new definition of x, this is equal to 1 minus x. This is equal to 1 minus the new value of x, it is sine square theta. So 1 minus sine square theta is equal to what? 1 minus sine square from trigonometrical knowledge. So 1 minus sine square. So, but we do remember that sine square of theta plus cos square of theta, this is equal to 1. So it means that if you want to make cos square theta the subject for this expression, for this identity, we have cos square theta is equal to 1 minus sine square theta. 1 minus sine square theta. So if that's the case, we say that this is 1 minus x is equal to 1 minus sine square theta. This is equal to what? Cos square theta. For that case, where we have 1 minus x, we'll substitute it with cos square theta, and this make equation 3. So again, just this is for the matter of learning. I round it for the matter of learning. Don't round it down. Remember, this is question 2, this is question 1, question 2, question 3. Do you enjoy how Olenjolain is deriving formulas and solving problems? If the answer is yes, I want to tell you, give all the glory and thanks to God who lives in me, who is teaching you, because there is a living God who lives in me, who is teaching you, and open your mind to understanding this concept and become simpler and simpler and simpler and simpler and simpler, right? So let us keep on. So we know what is x and what is 1 minus x. You know another challenge. We don't know what is dx, and we don't have new limits according to the variable of u. So we have x is equal to what? Is equal to sine square of theta. So to get the x, we have to differentiate this expression. So we differentiate x with respect to x. So d dx, if we differentiate the sine square theta, we get twice sine theta, then we have to differentiate sine of theta. If we differentiate sine of theta, we get cos theta. Okay? We get what? Cos theta, but here we have what? D theta dx. So d dx, we get 1. Okay? We get 1. Then this is twice sine of theta, cos of theta. Then we have what? D theta dx. Okay? So we want to make dx the subject. So to make dx the subject, we have to multiply by dx into both sides. So this is 2 times theta. This is cos theta d theta. So 1 times dx, it's dx. This is equal to 2 sin theta, then cos theta d theta. So this is equation 4. You know what the remaining part? Change the limits. Change the limits. So let us make the third step to be changing the limits. So the third step, change limits from x, from limits of x to limits of theta. How do we change? We have to recall. We have let x is equal to sine square theta. We know, so the limits we are being given in equation 1 are the limits of 40 of x. Here we need limits of theta. So the next step, you know, what should we do? We have x, we have to do simplification on this equation 2. So the simplification, we have to make theta the subject. So make theta the subject. Make theta the subject. So to make theta the subject, we have to square to both sides. So on this side, we have the square root of x is equal to sine of theta. So then divide by sine, on this side divide by sine. So sine and sine cancel. So we have what? We have 1 over sine of under root x. This is equal to theta. So we have theta 1 over sine. This in other words is sine inverse of under root x. So from there, we can find the lower limit. So the lower limit now of theta will be found when the value of x is equal to 0. So we have to find sine inverse of square root of 0. So sine inverse of square root of 0, this is equivalent to sine inverse of 0. So sine of 0 it is 0, so sine inverse of 0 it is 0. So our lower limit it is 30, it is 0. Okay? Then here it is. Let us find the upper limit. Okay? So what is the upper limit of x? It was 1. So let us find the sine inverse of 40 under root of 1. So sine inverse of under root of 1, this is equal to sine inverse of under root of 1 is 1. So sine inverse of 1, this is equal to 90 degrees. But 90 degree can be expressed in radian. So this is equal to pi over 2 radian. Okay? So our upper limit is equal to this. Okay? So right now, we have all our important information. Question 3. This is question 4. So this is the lower limit. And this is the upper limit, which is pi over 2. Okay? Keep meditating. Okay. So I believe that you enjoy the beauty of higher engineering mathematics and higher scientific mathematics. Okay? Higher scientific mathematics means mathematics we apply in science. So we go into the first step. The first step, my dear students, you say that now it's the time to substitute equation 2. You remember question 2, this one. Question 3, you remember question 3, this one. Question 4, you remember question 4, this one. And what? And the new limits. I'm writing these steps in order to reduce too much hassling to my students when they do revision, because in learning there is the moment that you can forget the stuff. So in mathematics, one of the challenges that I discovered when I did my research, why many students fail to understand mathematics. One of the reasons in mathematics we write numbers and letters so much. So sometimes we don't write the steps that you have done, or we have followed the step that you have done in order to go to the next step. So this I call it the special teaching aids that God has given me. in all my responsibility of teaching any module, any course, any subject from Form 1 to undergraduate level. Means because I used to teach Form 1, Form 2, Form 3, Form 4, Form 5, Form 6. Ordinary diploma, first year, second year diploma, second year diploma, first year undergraduate, second year undergraduate, third year undergraduate, fourth year undergraduate. I thank God by His own grace for that capability. I used to follow the same, or to use the same teaching aids to write the steps that we are following on solving the problem, rather than speaking them. I speak them and explain them and write them. So later on, when you will come to do revisions, it's very simple for you to know what did we do, what did we do in order to achieve the point that where we are. All right? Have you received a new technique and new teaching aids of Olenjolai from the Lord? Thank you for receiving. So substitute equation 2, 3, 4 and new limits in equation 1. So do you remember equation 1? Beta of m comma n is equal to what? Is equal to integral from 0 to 1. Then we have x power m minus 1 times 1 minus x power n minus 1 dx. So now let us substitute our new variables. So we start with limit. What the lower limit? The lower limit is 0. So here we have 0. So we integrate from 0. What the upper limit? The upper limit is pi over 2. So integrate to pi over 2. Then we need x. What is x? X is equal to what? Sine square theta. But what the index of sine of x is m minus 1. Then we have what? 1 minus x. What is 1 minus x? It's cos square theta. What the index of 1 minus x? It is n minus 1. Okay? Then we count the x. What the value of the x is 2 sine. So here we have 2 sine theta multiplied by cos theta d theta. So now the next step, we have to simplify to get equation what? 5. So beta of m comma n, first of all, 2 it's constant, we have to take it out of the integral sign. So here we have 2, then we integrate from what? From 0 to pi over 2. Alright, from 0 to pi over 2. Then here we are. So here we have what? Sine of what? Of theta. Then we say what? So this is 2 times what? M minus 1. So here it is. We have what? Cos of what? Of theta. Then power what? Power 2 times what? Times n minus 1. Right? So you have a bracket like this. Then you have what? Sin theta. Times what? Sin theta. Then you have what? Cos theta. Then what? Theta. Okay, so let us continue. So on right hand side we have 2 integral from 0 to pi over 2. Then we have what? Sine of m over theta power what? 2 times m, it is 2m minus, so open the bracket, 2 times 1 minus 1. Then you have what? Open bracket, we have cos of what? Cos of theta. So open the bracket, 2 times n, it is 2n minus 2 times 1, it is 2. Then here we have what? We have sine of what? Sine of theta times what? Cos of theta d theta. Okay. But we have like terms. Sin theta and tan theta alike, cos theta and cos theta alike. So we go into the fifth step. Fifth step, we say that simplify what? Like terms. Like terms of what? Equation 5 above. Suppose that this is equation 5. Okay? Wonderful. Okay, so if that's the case, then our equation 5 is beta of m comma n is equal to phi's integral from 0 to pi over 2. Then here we have what? Sine of theta powered 2m minus 2. Then multiply by its like term. So the like terms of sine theta, it's tan theta power 1. So here we have what? Sine of theta, but this one power 1. So same base, we add the exponent. Then multiply by what? Cosine. Cosine of 40 of theta powered 2n minus 1. Then we multiply with what? Slight term, it's called theta power 1, then the theta. Ladies and gentlemen, from the laws of exponent that we taught you at the first chapter in basic mathematics during your secondary education, ordinary secondary education, then we told you whenever you are multiplying to exponential expression of the same base, then we can add the exponents, right? Remember that. So here we are multiplying the two exponential functions of the same base, sine theta, the same base, so we can add the exponents. So now we are going into that point where we have what? So beta of m comma n is equal to 2. Integral from 0 to what? To pi over 2. So there we have what? We have sine of theta powered 2m minus 2 plus 1. Then you have what? Cosine of theta powered by 2n minus 2 plus 1 d theta. So beta of m comma n is equal to 2. Integral from 0 to pi over 2. So here we have what? Sine of theta. Sine of theta, 2m minus 2 plus 1. This is equal to what? 2m minus 1. Then here it is what? Cos of theta, 2n minus 2 plus 1. This is 2n minus 1. Then what? The theta. Then we have the formula. Wonderful. So beta of m comma n, the polar form of beta function, or the trigonometrical form of beta function, it's 2 times what? 0 to pi over 2. Then we have what? Sine of theta power 2m minus 1. Then you have what? Cos of, okay, so let me put the whole bracket like this. Cos of what? Of theta power 2n minus 1 d theta. So you can express this formula, and it's a very important formula for the rest of your life. Okay, so if that's the case, then we say, or we can write the same formula that beta of m comma n is equal to 2 times integral from 0 to pi over 2. Remember the limits that have changed now. Then you have sine of 2m minus 1 theta. Then cos what? 2n means cos of theta power 2n. Just like this, okay? Like this. Then what is the theta? So you can also write in this form. So this is the trigonometrical form of beta function. Did you understand? Please tell me in the comment section below. Did you find that this information helps you? Okay, thank you for your patience. How many forms of beta function, of formula of beta function remain? 2. Factorial notation in beta function in factorial notation, and beta function in gamma function. Right? Are you ready? Do you still have some space so that I can download that information in your mind? So let us go into the business. Okay. So for the other two formula, there's no need just to derive. This formula, I didn't see its derivation, you can find it, but it's stated like this way. So we say that the third alternative formula of what? Of beta function in factorial notation. In factorial notation. So we taught you the concepts of factorial for the first time in probability as factorial function. So let me give you the formula just like the Cartesian form. If number m and number n are the element of positive integers, and they form positive integers, this to say that m is the element of positive integer, also n is the element of what? It's the element of positive what? Positive integer. That I mean. Then beta of m comma n is equal to m minus 1 factorial times n minus 1 factorial divided by m plus n minus 1 factorial. So this is a factorial form of beta function. In some circumstances, you can use that formula, but it has limitation. Okay? So you see the limitation of the formula above is that is the value of m and n are what? The value of m and n are positive integers. So if the value of m or n or both is not fractions, then that formula is not valid. Okay? So for example, it means if m, for example, what does this sentence means? If m is 2 and n is 4, that formula is useful because 2 minus 1 is 1. So 1 factorial is easily formed. Then 4 minus 1 is 3. 3 factorial, you know it is 60. So 1 factorial is 1. So 1 times 60 is possible. Then we say that the 2 plus 4 is 6 minus 1 is 5. 5 factorial, you just know. So that's the meaning of this sentence. But what if the value of m is 3 over 2 and the value of n it is 4? For this case, 3 over 2 minus 1 is a half. We cannot find at this level a half factorial. So that's why I say that this is the good formula. It's useful when the value of m and n are positive integers. If the value of these two variables, these two independent variables, is not the positive integer, then that formula will not be in use. Okay? So if you have any question, please don't hesitate to ask in the comment section. I ask you to subscribe. We have a vision of recording more than 600 videos of high definition that will be teaching undergraduate students about different modules and courses. Almost we'll be teaching 12 modules or 12 modules or courses of what high engineering and scientific mathematics by using TCU and NACTE curriculum. So I'm also responsible to teach 4 modules. I have a responsibility to teach 4 modules by using the curriculums of Dar es Salaam Institute of Technology, representing all the NACTE institutions, colleges, and universities at undergraduate level. I'll be teaching 4 modules of University of Dar es Salaam, representing all the institutions, colleges, and university engineering, or in the University of Engineering and Science, that under TCU. And I'll be teaching 4 modules of University of Dodoma, right? Yeah, so it means total 4 courses. So total makes 4, 10, 3, is 12. So 12. So that, according to my research and my estimation and the vision that in my mind, there is a picture of more than 600 videos of higher engineering and scientific mathematics that will be accessible for in present and future generations of scientists and engineers who want to go into the extraordinary step of understanding and applying the wisdom of 40 high engineering mathematics. So again, I know that in your heart you receive this content free. This is my free willing thanksgiving to my God who has given me a gift of teaching. So this is my free willing thanksgiving. You have to pay for this program. You have to pay for this video. Even for the single lecture, you have to pay for. But I thank God. This is my thanksgiving offering to my heart, to my God who has built the gift of teaching in me, just like the gift of flying in beds, right? But also God give you invitation in case you feel from your heart you want to offer God your free willing thanksgiving offering of any amount, even 50 Tanzania shillings, 100 Tanzania shillings, 200 Tanzania shillings, 500, 10,000 Tanzania shillings, 20 US dollar, maybe 400 euro, or maybe 1,000 US dollar, 1 million Tanzania shillings. Don't hesitate. So you may send your free willing thanksgiving through this telephone number 07597453331, and your free willing thanksgiving will be received with much thanks, and God will bless you because that's the meanings of offering. And I want to tell you that you be used it to pay for the running cost to make sure that I do production, I produce, and I multiply what is in me for all the for more than 600 videos that will be the videos teaching undergraduate or bachelor students in engineering and science by using the syllabus and curriculums of Tanzania, which also will have a focus of international mindset, because what I'm teaching you right now in advanced curriculums, this is a concept which is covered in many institutions, colleges, and universities in the entire world. So I'm not teaching only Tanzanian, I'm using the syllabus and curriculums of Tanzanians to teach Africans, to teach Europeans, to teach Americans, to teach Australians, to teach Asians. So keep praying for me. I'm praying for you. This is intensive business, but God is at work. Tell your neighbor, God in Olenjolain is at work. Okay, so let us go. So ladies and gentlemen, so we say, let me teach you relationship better. I'll say that relationship, we say that in formula of beta function in gamma function. So this one we can just we can write a subtitle: relationship between beta function, relationship between beta function and the gamma function. This will give us the fourth form of beta function. If you join me right now, remember to subscribe in order for you to get notification when lecture 9 will be on air. Relationship between beta function and gamma function. Okay? In bracket, we say that beta Okay, formula of what? Formula of beta function, formula of beta function in gamma function. This we can derive it from the third formula. Remember, this is the third formula. So if we know this third formula and use the gamma properties, we can derive the first formula. Are you ready for that? You can pause the video and try yourself, because I know you're a great mathematician. Okay. So you see that derivation. So this might be a question. Derive the formula of beta function in gamma function. Gamma function, okay, from this formula, beta of m comma n. This is equal to m minus 1 factorial and then n minus 1 factorial of what? M plus n minus 1 factorial. So this is given. Solution, you can pause the video and try to solve this question yourself, because you are acceptable and intelligent engineer. Pause the video and try on the rough paper. Okay, thank you for trying. Let us do correction. So in order to derive the relationship, however, that you don't know how will it look like, okay, this is the first step that we have to, first of all, we have to number the given formula. Beta of m comma n is equal to m minus 1 factorial. Then we have n minus 1 factorial. Then you have what? M plus n minus 1 factorial. So this is question 1. Okay, so if that the case, if this is the case, if this is the case, we say, okay, so this is the first step. Can recall because it's given, okay, so it has to consider. The second step, ladies and gentlemen, we call the property of gamma. So recall that I taught you and I proved it for you, gamma of n plus 1. This is equal to n gamma of n. You remember that the first property of gamma that I taught you in lecture 2. Lecture 2 or lecture 1. Don't remember the numbering. Something may confuse the numbering. But that is not the case. Okay, so if that's the case, we say that, so our variable here it is n plus what? 1. That's the expression that we have. Okay, so we say that therefore for m minus 1, which is this item, for m minus 1 factorial, okay, yes, and this also, yeah, so we say that gamma, so remember that we say gamma, we combine two properties, so we told you again that gamma of n plus 1 is equal to n factorial. Left hand side of this equation is equal to left hand side of this equation. So therefore we say gamma of n plus 1 is equal to what? N gamma of n, this is equal to n factorial. So suppose that, okay, I'm afraid to call that is question 2. So we say that if for what? So for m minus 1 factorial, for m minus 1 what? Factorial. What does it mean? for n minus 1 factorial, we say that, okay, we can define as what? So we have left hand side. So we like to get the right hand side. So it means that from here, we have what? Gamma of n plus 1 is equal to n factorial. So let this call it equation 3. So listen carefully. So for this case, the first term of our numerator, we have m minus 1 factorial. So we have what we have on right hand side. What should we find on the left hand side? Listen carefully. In other words, because I know my students there, in other words, also n factorial is equal to gamma of n plus 1. How about what? M minus 1 factorial. So m minus 1 means this is our n. So it's equal to what? So we take this n, we substitute in positions of n here. So this is equal to gamma of m minus 1, which the value of n plus what? 1. So simplify. So if you open bracket, this is equal to gamma of m minus 1 plus 1. Alright? So for that case, m minus 1 from equation 1 is equal to what? M minus 1 plus 1 is equal to m. So it means this is equal to gamma of m, and this will make equation 4. Okay? Again, we have n minus 1 factorial. So we say that for n minus 1 factorial, then this is equal to what? So we refer our formula. So n minus 1 factorial, n minus 1 is equivalent to m. So this one is equivalent to this. So as we took this to put here, plus 1, so we take this one and replace n, and then we add 1. So this is equal to gamma of what? Of n minus 1 plus what? 1. So we say that n minus 1 factorial. This is equal to what? Gamma. N minus 1 plus 1, it's n. Okay, so this will make your equation 5. Equation 5. So equation 5. Then here it is. We have again what? The denominator. For what? How about m plus n minus 1 factorial? This is equal to what? So this is equal to this. So our value of n here, this one is equivalent to n. So we'll take this and replace in the positions of n plus 1. So this is equal to what? Gamma of m plus n minus 1 plus 1. So m plus n minus 1 plus 1. So negative 1 plus 1, it's 0. So we say m plus n minus 1 factorial. This is equal to gamma of m plus n. So this will make it equation 6. Okay? Wonderful. Hi, Julian. Mathematics is beautiful. So that's the second step. Ladies and gentlemen, we didn't achieve our goal. So we go to the third step. You know the third step? Now, we substitute. Substitute equation what? Substitute equation 4, equation 5. Equation 5. This is equation 4, equation 5, and the 6. And equation 6 in equation 1 above. Where is equation 1? This one. So beta of m comma n, which was in numerator m minus 1 factorial, and here m minus 1 factorial is equal to gamma of n. Gamma of n. Then we have n minus 1 factorial, which is equal to gamma of n. over what? Over gamma of m plus n, because in the denominator we have m plus n minus 1, which is equal to gamma of m plus n. So that's the response. So beta of m comma n is equal to that one, and that is the formula or the relationship between beta and gamma function. So this is the function. So mean that we say this is function. So beta of m comma n, simply remember this formula and remember the first formula of beta function, and remember the second formula of beta function, and remember this. The third formula you can remember, or you can just leave it. Just you can know it, but we don't have more application because of its limitation. Okay, so beta of m comma n is equal to 30 gamma of m times gamma of n over gamma of m plus n. The goodness or the advantage of this formula, it does not have limitation like the first one. So the above formula is used to find beta functions of both integers and non-integers. Okay, so this is formula 4, if you want to number. So you say that the formula above of beta function is used to find beta function of both integers and the non-integers. So both integers and what? And non-integers. That's the response, or that's the very important condition. Okay? So if that's the case, it's a time now to give you the homework. Still have so many information about beta function and gamma function, because remember that gamma function does not depend beta function, but beta function depend gamma function. So homework 8, and this is example 22, and refer, I took it from DIT final exam or end of semester exam or university exam. Here we call it FE, of which year? Of 2014 to 15. 2014-15, and the question asks you that, prove that beta of k, 1 is equal to 1 over k. If you do that, or if a student did this in that exam, he or she will be rewarded 2 to 3 marks. So you can try it. Prove that beta of k, 1 is equal to 1 over k. That is. Okay? So I know some students, which formula should they use? The first one, the second one, the third one, the fourth one? That's the challenge I want to leave for you. When you check this question, which is the simplest formula among the 4 formulas that I've taught you about 30 beta function? Ladies and gentlemen, I would like to say that this is the end of lecture 8, which was all about general introductions of beta function. These are the 4 formulas of beta function that you are going to use repeatedly in solving beta, or in solving problems about improper integrals of beta by using the beta function. So remember, the limits for the beta are not the limits of 40, are not the same as the limits of gamma. In gamma, at least one limit should be infinite, while in beta, both limits are defined. It can be 0 to 1, 0 to 2, 0 to 3, 0 to 4, it depends. And then another thing that I've been building up as a mindset in your mindset, how you can change the integral, which is in a particular, how can you change the independent variable of the integrals of the certain integral into the other one without affecting the truth of the equations of the function. So my dear students, I have given you so many information in case that you find until the end of this lecture you have been confused. Don't panic, take a rest, then try to learn this content on the next day. That's the goodness of the digital, because if you are sick or if maybe you fail to understand, you can watch this video several times as well as you can. This is Olenjolain from the beautiful country Tanzania, who is national and international teacher of higher engineering and scientific mathematics for the Tanzania. I want to warn you this as my dear students or a viewer of this video. Remember that Olenjolain does not know everything about higher engineering and scientific mathematics. Again, Olenjolain does not know everything about advanced calculus. Again, Olenjolain does not know everything about beta function. I just know small portions. I am always learning new concepts about mathematics because, as I said, mathematics is built in me. I am mathematics is me. So mathematics, it's the subject of my own life. What I'm teaching you is what I apply in my daily life on solving my own problems, my family problems, my tribal problems, my national problems, the national problems, the international problems. I would like to apply the concepts of mathematics, right? But remember, I know a small portion of what of gamma function. I know small portions of advanced calculus. I know small portions of high engineering scientific mathematics. I know small portions of engineering mathematics. I know small portions of higher scientific mathematics. But I have a responsibility to teach others what I know. That's why that is what I'm doing in this program. So you should not boast me up. Give God all the glory and honor for everything that I'm doing, because tell your neighbor, God in Olenjolai is at work. That's the phrase. I want to leave a challenge in you, a mindset. Take a moment, at least a minute or 3 minutes, to think, where are you going to apply this information on solving real life engineering problem? So think, challenge yourself, check the environment, check the fact, check the concept that you have absorbed. Because we are not teaching you these contents just for wastage of time. We have particular application. But that particular applications is not revealed, it's not open to everybody. It's actually hidden for few people to dig in and get its applications. And they will change the world, and they will change the nation, and they will change the generation. I love you so much. This is my freewheeling thanksgiving to the present generations of engineers and scientists and future generations of engineers and scientists. This is the analog and digital international and national teacher Olenjolain from Tanzania. Keep enjoying the beautiful gamma function and beta function. Keep enjoying the beauty of advanced calculus. Keep enjoying the beauty of high engineering mathematics, and keep enjoying the beauty of higher scientific mathematics for scientists. Until we meet in the next session, I invite you to join me in the lecture 9, when I will be starting solving problems of beta function by using the formulas that we learned in lecture 8. So may God bless you and keep you. Meet you in the next session. I love you. May God bless you and keep you until we meet in the next lecture, that is lecture 9.